Okay, so I'm going to try to explain every step of this problem along the way and probably break it down more than you would when you're actually doing them. But again, I'm going to try to um, hit every little small piece of it. So on the right, we have 2 square root of 7, and there's nothing that we can do with that because 7 doesn't have any factors that are perfect squares. But on the left, we do have a square root of 180, and 180 does have some factors that are perfect squares. And so there are multiple ways to do this. I saw that 9 goes into 180 20 times. There must be a bigger number that goes into 180 that's a perfect square. Um, I'm not sure what that number is. It's probably 36, but I'm not going to worry about it because this is the way that I would actually approach it. I would just start taking numbers out that come to me easily until I run out of them. So 9 is a perfect square. 20 also has a factor that's a perfect square, and so that would be 4. So we want to split 20 up into 4 times 5 because we'll be factoring out that, or we'll be taking the square root of that 4 as well. I don't know why I keep forgetting to write the 2. So if I focus on the left side there, I've got 2 perfect squares inside the radical symbol. So I'll take out the square root of 9, which is 3. So 3 times 11 makes 33. Leaves both 4 and 5 inside the radical symbol. And I could take the square root of 4, which is 2. And so 2 times 33 is 66, which leaves 5 inside the radical symbol. And I'm just looking at the numbers. It would have been 36 times 5. So alternatively, you could do, if you recognize that 36 goes into 180, we'll just show that this produces the same result. So 36 times 5 makes 180 also. And the square root of 36 is 6. 6 times 11 is 66. And so these two things that I'm going to box in green, you could get to it either way, by factoring out a 9 and a 4 like I did, or by factoring out a 36. You're going to end up with the same thing. Doesn't matter. I just noticed the 9 first and then had to deal with the 4 as well. So I'll continue down the one on the left. We've got is a division problem now, and so I'm going to rewrite it as a fraction. So 66 square root of 5 over 2 square root of 7. And so for some reason, I don't know why, mathematicians don't like it when there's a radical symbol in the denominator. And so we'll deal with that in just a minute. But the first piece is we need to look at the whole numbers that are outside the radical symbol, and notice we've got 66 divided by 2. That's going to simplify to be 33 square root of 5 over square root of 7. And I could put a 1 right here if I wanted to. I don't need to, so I'm not going to. But now we have to deal with this problem that we have in the denominator where we have a radical in the denominator. And so the way to this thing is called rationalizing the denominator. We just basically pick a number that when we multiply both the numerator and the denominator by that number, just like creating a common fraction, like 2/3 times 6 over 6 is 12 over 18. 2/3 and 12 over 18 are equivalent because we chose to multiply the numerator and denominator by the same thing. And so rationalizing the denominator has the same idea. We just need to pick a number that will make the square root symbol disappear from the denominator. In this instance, our number is going to be square root of 7. So 33 square root of 5 over square root of 7. We're going to multiply both the numerator and denominator by square root of 7. And so in the top part here, we'll have 33 times 1, which is just going to stay 33. And we will have square root of 5 times square root of 7, which is going to make 33 square root of 35. And then the denominator, square root of 7 times square root of 7, I'll write that over here on the side. Square root of 7 times square root of 7 is equal to the square root of 7 squared, which is going to be 7. Actually, one moment. And so in the denominator, we still have a 7 because square root of 7 times square root of 7 just makes 7. And so the piece on here, I'm assuming that this is the work that you did. The piece we need to be mindful of is that we cannot separate this 2 and the square root of 7 right here. The square root of 7 will need to stay with the 2 when it moves to the denominator here. And then again at the end, as I did, we want to make sure that we get rid of that radical symbol in the denominator by multiplying by itself. And again, square root of 7 times square root of 7 is just 7. So what I get for this problem is right there. And so I'll zoom out a bit, leave the whole thing here for you. And if you have any follow-up questions, I'll be glad to do my best to answer them for you.